Hey, Jack, thanks for joining me for Lead Time Chats.
Hey, Gene, thanks so much for having me. This is really
Yeah.
nice.
So today we're going to talk about the topic of technical debt. So both paying down technical debt and accruing technical debt. And to start off, Jack, can you explain at a high level, like how do you think about technical debt and financing it?
Yeah, so I like the word financing. I use that a lot when I talk about it because I think we all have an experience of technical debt and like some nuance to like the stuff that's the worst or the stuff that like is the most urgent. Um, but there's like not a whole lot of sophistication to measuring it, or we might try, but it's mostly just um, different heuristics of like how fast is it getting really bad, or how many of us on the team are impacted by it, or how often do we have to pay the cost. But there's a flip side of that, which is like debt financing isn't just people taking on debt. It's they're taking on debt in order to make investments. Like if you are wise about this, you could take out debt at a known interest rate, hopefully low, and then make interest or make investments at a ROI that's higher. And if you get the numbers right, if you're right about the values, then like you profit. And I think that's actually what we do in software engineering most of the time, particularly in startups, right? Where time is extremely short. So you got to take on a lot of debt, actually. Financially, the company's taking on debt, obligations to shareholders, but also sometimes even a debt financing round. And then you cut corners in the code and the systems, you have to, in order to do something. But the question is, what's that something? And one version of that investment is features you launch today, which is great and definitely useful. But another is like something that prevents you from taking on debt in the future. What are the things that are investments you make now that prevent future debt? And my favorite example of this, I think at another company might be Amazon, which kind of famously ran thin to zero margins from like the beginning to now. Like every dollar brought back in was put back in R&D. And teams were frugal and they were fast, but they also like didn't just do things for the short term. There's very little in AWS, for example. There's very few services that have been shut down because they were built quickly and then like crashed. That doesn't happen. Google shuts everything down, but AWS, every AWS service is launched. If it's deprecated, it's like, okay, in 5 years, we're shutting down the service. We're like, okay, fine.
Right.
There's some kind of different timeline being taken into account. And I think that one of the things that we as engineering leaders could do a better job of is thinking about what are the shortcuts my team is taking now, or what are the places where we have debt, where it's so bad we need to address it right now. And what are the areas that are so ripe for investment that independent of anything that we want to do for product reasons, we should be making investments right now because it'll pay off.
Yeah.
A simple example might be like consolidation. You simplify the system, that's going to pay off forever. But both sides are really important, I think.
Yeah, I like this mental model you have of debt, because I think a lot of times people's mental model of it or team's mental model of it is quite simplistic, right? Like it's either, oh yeah, this is debt we should pay off, or this is debt we shouldn't pay off. Or it's even more simple of just like, oh, we have so much technical debt, we need to work on it, right? Without and if you talk to a startup, I mean, you and I know, like if we talk to a startup and someone's like, oh my God, this code base has so much technical debt, I mean, we'd be like, good, like
yeah.
right? Like it would be really bad if you had zero technical debt. But I think for some engineers, that's kind of they're like, oh, we should do everything right, and then we would have no technical debt. But actually it's this like this trade-off and prioritization problem. And obviously, like, the first car I bought, it was 0% interest. So I just paid it every month because I was like, well, technically I can then spend that money and invest it somewhere else. But like, we don't tend to think about it the same way when we approach technical debt.
Yeah. I think you're right about a startup that has no technical debt has such a small code base that it probably doesn't actually do anything. And that startup is not going to exist in like 9 months,
Right.
One of the things that the 0% interest reminds me of this question somebody asked me once about why is it that the team I was on, we were spending time doing technical debt work that was like 20% time or something. Like it was It was an initiative to pay down technical debt, but it was very broad. It was like, we're just going to spend, 1 day a week, or 20% of us or something are going to work on technical debt. And somebody said, that's like if you had a student loan and a payday loan, and you had $2 and you put one on each. Like, this is not a wise distribution of time. Like, let's find the highest debt interest rate and let's just pay that down. And so we came up with this simple system where, well, it seemed simple at the time. I don't know if it was usable, but it was, what are the different dimensions across which each problematic area is getting worse? So if it gets worse with every new record that goes in the debt database, well, then what's our forecasted data growth? If it gets worse with every new engineer you add to the team, okay, what's our forecast to hiring growth? If it gets worse with every new user you add or every new feature you add to the system, then we just sort of look at, well, okay, how bad is it across each of those, and how many of those does it make it worse? Like, there might be some sort of core tooling where every time you add any new feature, or the data grows, or every day that goes by, it like gets worse. There's this like combinatorial explosion of complexity. You're like, okay,
you're like, this is a five vector
technical
debt
totally.
problem.
Or it's like O of n squared or something. Like, this is really bad, right? And then there are other places. I usually see it as like, there's a static page somewhere that's in Backbone, or it's jQuery, and it's so ugly. It works, and nothing depends on it, and it depends on nothing. When is what is the interest rate on that? It's a 0% loan. You can pay that down tomorrow, or in 5 years, and it takes the exact same amount to pay. But something getting worse, especially if it's in the middle of your system where you have to encounter it a lot, and every day you're making changes, maybe it's in your build system or your development setup, and every day you're paying the price, that is a very, very high interest rate. So if you have some time, pay that down. And personally, I think that the whole, like, we're going to spend this much time on technical debt is the wrong framing, where it's really, what are the properties we want to be true about the system? How bad should the worst part of it be? And then just like make it better. Just decide our goal is nobody gets frustrated building this kind of stuff, and then this known debt is just gone. And just work on it until it's done. The same way that you would work on a product until it's finished, launch it.
Right. You wouldn't just say like, oh, let's send 2 engineers over to work on that feature for 2 weeks and then we'll see where it gets to.
It's one thing to cut scope, but launching a known fully broken feature, it's going to like cost so much time and like brand, and customers will churn. Same thing with technical debt. If you're going to like migrate from a V1 to a V2 and you only go halfway, you're in such a worse world than if you just kept with V1, right?
Oh my gosh. One of my proudest accomplishments when I was at Medium was kind of dealing with the aftermath of one of those situations. But it was like, someone's like, oh, here's the new way to do it. And then they'd get through maybe 10 to 20% and then drop it. And then like a year later, someone would be like, oh, this is inconsistent. Here's the new way to do it, 10 to 20%. And then it was like 3 or 4 of these like piled on top of each other. And like whoever you asked would have a different answer of like how to thread everything through the whole front end and back end. I was like, this is not working. Like we just need to choose one area, we need to choose one and then like get everything there so that people are not so confused when they're building a new feature.
How did you get to the end of that work? How did you actually get to finish trying to fix that?
So there were various, a lot of it was just like organization, like, okay, here's the spreadsheet of the like 200 things we need to migrate. Okay. Make it fun. Like when it's done, it like turns green or something. People are like, ooh, I want to do some of those. And I'd schedule like 1-dayers where like we just have 1 day. I'm like, okay, whoever's free that day, come go in this room. We'll like, migrate a few. I migrated a bunch. And then at the end, there were a bunch that were the 0 interest. And then we just like put them in a file and we were like, legacy notes, like don't touch them. But then awesome. It's clear, right? It's clear, like, okay, clearly this is not worth the time it would take to disentangle them and migrate them. But that's okay. We've like acknowledged that that's kind of we didn't have that terminology, but this is like the 0% interest that we're taking on here.
Yeah, I love that. I love that. And then it simplifies the system so that there's just fewer things for anybody to have to worry about in the
Right. And if
future.
anyone ever gets in there, it's in the file legacy, right? And so
Yeah,
okay, this is not the way to do things now. So it's like
right.
just like where you put it and the semantics are important.
That's really
I'm
great.
curious, so this is kind of a I don't know how you'll take this, but I feel like people are not necessarily great with personal finance. So if you
Yeah.
if your analogy you're using is kind of like finance related, do you find that people are like, oh, that makes sense? Or are they like, I don't even understand it for my personal finances. So like
This would probably explain why people's eyes glaze over as they use this one. Yeah. Yeah. No, I think of it like I'm not in financing. I do what you and I do for a living. I'm
right.
not in that. So I'm not even sure if my metaphor is right, but I think of it in terms of like one of those, capital funds that just looks for a business that has a lot of value in it that's struggling, and they go and they fix it. Like there's a way they can deploy this $100 million here, and then later it turns into $1 billion.
Mhm.
There's a discipline outside our line of work where people look for those opportunities and they take advantage of them and they get extraordinarily wealthy. And
Right.
most folks looking at that kind of activity, as long as there's no, shady stuff, would say, yeah, that is value creation. Something exists that didn't exist before. They like found the right lever and they pulled it really well. And
Mhm.
and actually that brings me into something that I think is kind of related, where if we're in a senior enough position in a company to start
Mhm.
being able to think about the kinds of long-term investments, one of the one of the things we've got to settle first is, what does this company have an appetite for in terms of product development? Like how broad can this company imagine the product growing? So
Mhm.
when I was at Square, I remember early on, people still get Stripe and Square confused. If you work at one, people assume you were like, they'll use the words interchangeably. Nobody can really tell the
Mhm.
difference, and that's fine. But early on, there was this key distinction where Stripe seemed to have this one main thing that was really good: the ability
Mhm.
to take credit card payments online. And Square had like this, that we call it the reader, everybody else called it the
Yeah.
dongle, and then a handful of other products, and went into the direction of merchant services more generally.
Mhm.
And it was a really different approach, two different approaches to how to design your system. Because if you're taking one great feature, one great product, and just scaling it, you build the infrastructure and the like internal platform one way. But if
Mhm.
you're creating a flagship product and then you want to use that just to fund 40 adjacent products,
Mhm.
you actually like build your system very differently. It's differently
Mhm.
shaped. Like if you're building Microsoft Word in an environment where you expect there to be Excel and PowerPoint and Access
Right.
and everything else, you just build it differently. You build your menus differently. You build your branding, your shared libraries, all of it. And so
Mhm.
one of the things that we need to figure out is, in the context of our business right now, what is the appetite for going broad? And if
Mm.
it's large, then we need to prepare our system for product number two, flagship product number two.
Mhm.
Slack started as a game, right? Flickr started as a game. That there's the product that you start the company with, and sometimes you pivot to a different one, or you just add a second one. And the ability to successfully do that pivot, or just add another product or 10 more products or 30 more products,
Mhm.
really depends on the investments made early on. So that's one of the things we need to do with that time and energy we recoup from paying down the big debts.
Yeah. That makes a lot of sense, because I think a lot of times people just think of technical debt as like, you open up a closet and it's cluttered. You're
Mm,
like, okay, I got to declutter the closet, or I got to make it tidy. But like, what are you doing that in service of, right? Or like, what are you doing that so that you have more time to do something else later on, or what are you not doing so that you can invest in the
exactly.
big bets, or the long-term investments?
Exactly. And there's this question of velocity kind of baked in all of this, where the debt is a high interest rate, not because it's rough to do, but it's because either it slows us down right now or it will stop us completely at some date in the future, right? There's
Mhm.
a cost in terms of our time that competes with the time we want to build new things with. But the flip side, the investments, they buy us time. Like there's a
Mhm.
velocity found there. And there's a lot of good literature, and like the book Accelerate is excellent on how to move fast. But most of the way we talk about it is quite linear. There's this closet, it's full of nasty stuff, it's making us go slow. We want to go fast. But I think there's another level of that particularly at the executive level of engineering leadership is, okay, there's a way to get stuff out of people's way so they move fast at like full speed. But once they're there, how do you make it so that they could possibly go faster than that? Like, what is full speed in your org? Like, how do you change the substrate of your company, of your engineering setup, so that full speed itself increases? You know, how do you create a system where you could hire 2 new grads and assign them to build a new product, mentored by a pretty senior person internally who could spend a few hours a week, and they're able to launch a new product in 3 months, just the 2 of them? What would have to be true for that to exist? If you think about that for a moment, you think of all these investments you'd have to make. Oh my gosh, we'll have to do documentation. We'll have to have shared libraries. Things have to make sense and be articulable. And the words we use in meetings to talk about our system have to match the names of database tables and source code files. Right? Those investments, I think, give us this radical acceleration, and not just an acceleration, like not just a high velocity, but like literally an acceleration. Over time, it goes faster, and it goes faster at getting faster. And there's something about those investments I think is a little hard to talk about, because we don't have a good speedometer, honestly. We don't know how to say this is the speed of engineering. It's just, here's how many commits we're making or so, or deploys, right? It's a little tough to, it's very subjective.
But one thing I'm hearing though, is that it's not just about the technical debt, right? There's organizational debt of like, how are we talking about these things? Are the ways we talk about it in the document matching, you know, the database tables, or these sorts of things that are not necessarily like, oh, we need to refactor this file. But I appreciate that the way you talk about technical debt is really connected to everything else, right? Because like one thing I've seen that is not, it's kind of an unhealthy dynamic is like, non-technical folks will kind of, you know, roll their eyes, and I was like, oh, engineers, they're always talking about how they need to refactor something and like pay down tech debt. And then engineers are always like, oh, my PM doesn't understand that like this is actually going to help us move faster. And so they're just like not understanding each other. But I guess what I'm hearing a lot from you is you're not even really talking about, like, maybe not even using the words tech debt, right? Like using other words like, you know, what do we need to do to get to this point? Or, you know, talking about the outcomes you want and what the tech debt is in service of, either accruing or paying down.
Exactly. And I do try to avoid specifically the phrase tech debt when possible, for exactly that reason, because tech debt is often framed as something where an engineer has to fight for the right to do the thing that the company needs. And often the engineer doesn't know the difference between this is something that bothers just me or something that's an existential threat to the company. You know, like if you do payment modeling of some kind and the math is wrong, existential threat. But if it's just like poorly organized and you're the only person who has to maintain it, like that's your own personal pain. And often doesn't know. But I like to think of it instead of talking about tech debt and like fighting for the right, I like to think in terms of inertia of the whole system. How big is the system? Not in terms of lines of code or data, but in terms of cognitive overhead. How many concepts might one run into when trying to make a change? You know, we're all familiar with spaghetti code where you change something over here and it, you know, messes with something over there. Systems just look just like that, whether it's spaghetti code in a function or an application or across an entire system or all the environments of a system. The larger the cognitive load is, the slower you can make any change. And product people get that totally. Like, because product and design run into the same problem. You know, if you've got 40 items in a menu at the top level, then they get that like, this is not an environment where you can be effective. So if you say, well, we could add this thing, but we've added so many things that this is really going to add more inertia to the system. Are you sure this is the last kind of change we'll need to make in this area for a while? And then even someone outside engineering can reason with that and say, actually, no, we have a lot of plans here. You better make it easy to work fast here. And then you can go do that.
Yeah. And I think that really highlights the importance of not just saying, oh, it's really hard to talk about, so we're not going to talk about it, but finding ways to talk about it that lands with, the people you have to work with. Because I have seen, I've talked to people who have said, oh yeah, the way I get around that of like having to fight for the right is that they just put in buffer time and then they do it, they kind of do it. But then what you're
Yeah.
saying is true. It's just like, for one engineer, it's hard for them to know, is that only affecting me or is it affecting, the whole engineering org, and also
Yeah.
poses an existential threat to the business. And so that feels like, that's always felt like a really unhealthy way to deal with it to me, of
Yeah.
like,
Yeah.
let me just like never talk to my PM or anyone else about tech debt, but just always add on a few extra days when I give my estimates, and then I'll just kind of like use that time to work on tech debt.
Yeah.
But I could see if communication is really poor and there's not a lot of trust, or I mean, that could be a way to get around it, but it's probably not
Yeah.
a good long-term
It's
solution.
good.
If you're, if you're thinking about how do you make the most high performing engineering org, that's probably not the best way.
Yeah. And this actually is the same shape of a problem that exists between any two teams, engineering or not, where I have data that's available to me, you have data that's available to you.
Mm-hmm.
I know some things that are important to do that you don't know about. So I will secretly do them and lie to you about the resources I'm consuming. And you know some things that are important to do to the company that I don't understand. So you will do the same. And then as long as we get lucky, there's no conflict. But inevitably, we're going to come into conflict. Like, I don't even know what Gene's team is doing there.
Mm-hmm.
You're the engineering lead and I'm the finance lead. And I'm like, my team is doing the right stuff. And we understand, and you don't understand it. And that's because you're ignorant about our thing. But what's missing is a way to actually combine those two sets of knowledge into a union and talk about that as a whole. What is it this company is doing? What debts has this company taken on generally? What obligations for future work does it carry? How do we reason about that? And building relationships enough to be able to have those conversations is, I think, absolutely worth it. Right now, I'm at Pathstream, this education startup that I absolutely love. And my product and design partners have really done the work to figure out what it's like to be in engineering. They don't all know all the details of the code, but they get it. So when I talk about inertia, when I talk about this hurts, and this part's not so painful to work in, they get it. And I can understand theirs well enough that we can put together this superset, and I don't have to fight for, okay, ignore these people while they do the right thing you don't understand.
Right. And some of that's not even tech debt related. That's just relationship building. Right?
It really is. Yeah.
Yeah. I remember one of the teams I was on at Medium, we had talked about like having a team offsite where we kind of like map out the tech debt and like the landscape of engineering, product, and design. Cause like product's got its own debt, right? Design's got its own debt. And we were like, what if we could get it so that, engineering had to present the product debt, and so kind of like build this empathy around like
that's
all
amazing.
these functions. Yeah.
I love that.
Yeah. But and that's just like empathy and relationship building as much as it is actually exposing where the debt is.
Yeah, I really like that. One thing that I think unifies those three disciplines pretty well is this metric that I learned from Alyssa Henry when I was at Square. She leads all of engineering at Square. And before that, she was at Microsoft. And before that, she founded Amazon S3. She I don't know the exact story, but it's something like she got 4 people and like just started the team. And now it's where everything is stored. But this metric that she uses was major features launched per engineer decade. And every organization has to do the work to figure out what is a major feature, or what is a feature, what's the value of a feature, are there different tiers? The important thing is that it's something end user visible. It doesn't matter about the internal changes. It's like, what new value has shipped from the company? So that's your numerator. And then you just take the entire headcount of engineering, or if you want, engineering, product, and design. And that's the denominator. And you track this metric, and your engineering, product, and design leads are suddenly very aligned. They're like, okay, well, this metric has been going down for the history of the company. Day one, we like create React app, and we're amazing. It was like major feature launched in 2 minutes by one person.
Yeah.
And now in the last year, we've had 80 people, and we've launched one half of a thing. Like, you face that metric, you stare that in the face, and suddenly you can talk about, man, we'd like this to be 10 times higher in 2 years. what would it take to get there? And then that conversation allows you to actually make some of these investments a little more tangible. How
Yeah.
would we make the actual things shipped by this company 10 times faster in a few years?
Mhm. I love that that metric is something that unites the three functions and that they're actually in control of, right? Because sometimes it's like,
Right.
oh, we want this product metric to go up by 10%. It's like, well, you don't know what users are going to do, right? Like
Yeah.
we don't have control over that. And so it's sort of a aspirational metric, but we can actually influence that metric of, what was it? Major products per engineering decade.
Exactly. Yeah.
I
Yeah.
love that.
And then within that, within the engineering product and design leads, engineering can own how many of the like agreed upon things that we want to launch actually get launched, whether they succeed or not. And then products can be held responsible by whether they succeed. You know, when they are built, do they succeed? Which is like, did you research the market? Do you know your users? Did you do tests well enough? And then design can be measured by like basically how frictionless is the experience,
Mhm.
how quickly is adoption increasing. And then I'm not a designer, so I don't know some of the better metrics, but engineering can be like, yeah,
Etc.
we launch way more. Yeah.
Cool. I guess bringing it back to tech debt, even though we've talked a lot about, what tech debt is in service of and team inertia and engineering team health, what mindsets or strategies have you found to be successful in spreading this general like approach and mindset to other engineers?
Yeah, I think the first conversation that has to happen is, what do we think we'll be working on in the future?
Mhm.
Because you can have a lot of drift within your organization around, this team will be taking shortcuts because their mandate is short term. And this team over here is fixing everything that they touch because their mandate is very long term. And the
Mhm.
moment that the team with the short term mandate tries to pass off some of their work to this other team, you've got relational breakdown that is entirely the fault of executives. Like
Mhm.
everybody's doing the right thing, but it doesn't fit together. So you need to have a conversation, I think, first around what parts of the system are just experiments, which
Mhm.
parts are real investments that we're committing to, and then what's the boundary between them. Don't confuse those. Then
Mhm.
within those, like if you're making experiments, there's like a bold bet new product or feature. That's great, do that, take a lot of debt on like the company was starting over, but use
Mhm.
libraries that are bulletproof and shared across the whole company, and do not
Mhm.
let that short-term thinking pollute the other stuff. And then on
Mhm.
the other side, things that you're going to need. The question I usually use to determine the sides is just, are we pretty sure we'll need this in 5 years? And it's like, okay,
Mhm.
and you just sort it out. The stuff you're pretty sure you'll need in 5 years needs to be correct. Just like
Mhm.
there's no real tolerance for not being correct. And the way you prioritize fixing things is really, it gets into like who's around to fix what and how inspired are they for the solution. So it does have to come
Mhm.
out of a conversation, but it's got to start with identifying, do we actually need this? And
Mhm.
then how bad do we think it's getting? How fast? You make
Yeah.
honestly one document with a list of the debt we think we have arranged top to bottom by roughly the category of how bad it's getting, how quickly. And I've seen
Mhm.
teams get very well aligned.
Great. Yeah, what was one thing you said earlier? Oh, yes. I think the guidance on when to take on a lot of tech debt is so important, because I think
Mm,
in the absence of that guidance, what I've seen is engineers then um they have this like, I feel like engineers are um given a lot of praise when they build things robustly, scalably. And so then in the absence of the guidance of like, no, you should take on abundant
yeah,
tech debt, then they
yeah,
feel like they're being bad engineers. And then they're not actually making the right decisions. Right. And so being
yeah,
super clear about, this is an experiment, take on as much tech debt as you can
yeah.
to make the product work as quickly as possible is like so important.
Totally. And that line between this is an experiment and this stuff isn't really helps engineers, particularly ones who are more senior and who've had to fix things for a while,
Mm-hmm.
let go and do those experiments and take on debt because they don't feel like they're compromising the work they just finished. They could,
Mm-hmm.
if they know that there's some sort of bulwark against it, then they can just go make a mess. And then it's
Yeah.
like a hack week, but it's a whole product, and
Yeah.
that's great. But they do need the guidance, and they also
Mm-hmm.
need the space that's well defined in which to do it.
Mm-hmm. Cool. Thank you so much, Jack. I've really appreciated hearing your mindset. And there's a lot of things that come to mind. I'm like, oh, we should make that list at Range. So I'm sure it'll
I
be
love it.
super helpful for other engineers as well.
Thank you so much, Gene. This is super fun.